What is going on, guys? Welcome back. In this video today, we're going to build a custom drawing classifier in Python. So an application that uses machine learning to classify your drawings as one of three customly defined classes. So we're going to start up the application. We're going to provide three custom categories or classes. So for example, circle, triangle, square. And then we're going to provide sample drawings to train the model. And the goal is to then use that model to make predictions on new drawings. So we're going to draw a triangle, we're going to draw a circle, then we're going to press on predict, and we're going to hopefully get triangle, circle, whatever we have drawn onto the canvas. That's the basic idea. And the good thing about the tool that we're going to write today is that it works with all different classes that come to mind. So you can do cars, you can do headphones, you can do books, you can do animals. Whatever you want, you can just provide that category name, you can provide sample drawings, and you can train the model to recognize this specific type of drawing. And this is a somewhat advanced or at least intermediate project. So we're going to write a lot of code. We're going to use machine learning. We're going to build a graphical user interface. So if you're a complete Python beginner, that might be a little bit too much for you. However, you can still follow along, but I think this is a video more targeted towards intermediate Python programmers. So let us get right into it. Alright, now before we get into the actual tutorial, I would like to show you what we're going to end up with here as a motivational preview up front. So I'm going to run the application that I have already prepared. And the first thing that we can do here is we can specify a project name. So let's call this shapes. And then let's define three classes. I'm going to call them triangle. Where is it now? Triangle, circle, and square. And then we have this graphical user interface here with a canvas. I can just draw on here. I can clear the canvas. I can increase the brush size. I can decrease the brush size like this. And then I can provide samples for the three different classes. Triangle, circle, square, they have their own button. So I can just go ahead now and draw a basic triangle. I can click on triangle. I can draw another triangle. And of course, to make this somewhat accurate, we would have to provide a couple of training samples. So not just 5 or something, but for the preview now, I'm not going to provide a ton of examples. I'm just going to write to draw 5 triangles, 5 circles, like this, and then 5 squares. This will probably not be entirely accurate because squares and circles can be quite similar. And if we just have 5 examples per class, it will probably not be a perfect model. However, once we have the training examples, what we can do is we can just click on train model. And then it says model successfully trained. And then hopefully this works now. If I provide a triangle and click on predict, it tells me it is probably a triangle. Let's try if it does the same thing for a circle. It says a triangle, maybe because I drew the circles like this. There you go. Drawing is probably a circle. And hopefully it recognizes a square. Yeah, probably a square. Somewhat accurate at least. And we also have a couple of different options here. So for example, I can change the model. You can see right now I'm using a linear support vector classifier. I can also use a k-neighbors classifier. I can use a logistic regression. I can use decision tree classifier, random forest classifier, and Gaussian naive Bayes. So let's see random forest classifier, train the model, and let's see if that also performs somewhat well. Triangle, circle, and circle. Okay. We would have to add more training data, but we can also save the model, load the model. We can save everything, so the whole project. Also, when I'm closing here, it asks me if I want to save my work. And this is what we're going to build in this video today. It's quite comprehensive. We're going to have to write a lot of code, but this is a very good project for intermediate Python programmers. All right, so we can now get started with the coding. And the first thing we need to do is we need to open up a command line and we need to install a couple of external Python packages by saying pip install. And we're going to install here NumPy. We're going to install Pillow. We're going to install opencv-python, and we're going to install scikit-learn. NumPy is what we're going to use to just work with arrays efficiently. Pillow and OpenCV are for working with images, and scikit-learn is for the machine learning part. So just install those packages. In my case, they're already installed, and then you can import them in the script. Now, for this video, we're going to write a lot of lines of code. In the prepared code on my second screen, I have 283 lines, so it's going to be quite comprehensive. However, this time, this might surprise you, the code will be probably available on GitHub. I already have a repository called Drawing Classifier. It's quite old. And after I'm done with the video, I'm probably going to update this file to be the code of this video tutorial. So you can check out the link in the description down below. You will probably find a link to the repository where you can just copy the code, or at least copy sections of the code. However, if you want to learn something, I recommend you type everything from scratch without copy pasting. So let's get started by opening up a new Python file, calling it main.py, and we're going to import a couple of things here. We're going to start by importing pickle, which is a core Python module. We're also going to import os.path. We're going to import numpy snp. We're going to import pil, P-I-L in capital letters for pillow. We're going to then also import cv2 as cv. So I'm going to structure it like that. Then we're going to import a bunch of tkinter stuff. So we're going to first say, or actually let's just go ahead for the sake of simplicity and let's say from tkinter import everything. Now, as always, this is not a good practice. If you're building an actual application that is used by people, that is something that works in production, that is something that's actually not just a tutorial, you should not use wildcard imports. You should always say from tkinter import file dialog, simple dialog, button, whatever. But for the sake of simplicity, I'm just going to import everything here. But this is not a good practice. We're also going to explicitly import down below, or actually, yeah, above is better. Import tkinter.messagebox. And I think that's it for the graphical user interface imports. We're then going to also say from scikit-learn.svm, we're going to import the linear support vector classifier. From scikit-learn.naive base, we're going to import Gaussian naive base. We're going to say from scikit-learn dot tree, we're going to import a decision tree classifier. From scikit-learn.neighbors, we're going to import a kneighbors classifier. And from scikit-learn.ensemble, we're going to import a random forest classifier. Now, you can add as many classifiers as you want. You can also just use one. You can remove one that you don't like. You can also use neural networks with TensorFlow if you want to. Those are just models that we can use. We're going to have the same training data. We're going to have the same mechanism of predicting. We're going to have the same graphical user interface. Adding and removing models is quite simple. So you can do that if you want to, but we're going to use those here for the video. So once we have that, we're going to now create a new class, which we're going to call Drawing Classifier. And we're going to have a simple init method. And the init method will basically only be used for defining attributes. We're going to set all of them to none. But we're going to talk about what these attributes basically are there for. So we're going to say self.class1, self.class2, and self.class3 are going to be equal, delete bookmark, are going to be equal to none, none, and none. Basically, those are going to just be the class names. So triangle, square, circle, for example. We're going to then also have self-class1 counter, self-class2 counter, and self-class3 counter. We're going to set those to none as well. And basically, those are going to just keep track of how many instances of sample drawings we already have for the respective classes. So when I add a triangle, if class 1 is a triangle, I'm going to have 1 here, 0 here, 0 here. We're going to use that to basically choose the file names, because we're going to store the samples in a directory with the name of the file being the number of the sample. And it's going to be in a directory for that respective class. That's the basic idea. Then we're going to say self-classifier equals none. We're going to say self.projectName is going to be equal to none. We're going to have self.root being equal to none. And we're going to have self.image. One, I think I call it image1 because image is a keyword. Not necessarily a keyword, but image, probably I used image somewhere else. So we're going to call this image1. Maybe we can change that later on. Basically, the classifier is just the model that we're going to use for the actual prediction and for the training. The project name is just the name of the directory that we're going to store all of this stuff in. The root is going to be the root tkinter window, and image1 is going to be something that we use to take the canvas, turn it into an image, store it, feed it into the machine learning model as a NumPy array and stuff like that. Then we're going to say self.status label. This is just important because we're going to change the status label. This is going to just be a label in tkinter or from tkinter because we're going to keep track of which model is being used at the moment. Then we're going to say the canvas also has to be a class attribute here or an object attribute here. And then self-draw is equal to none. Draw is going to be an image draw object from pillow, so pill.imageDraw, so that we can draw on the actual image. And then we're going to say self.brush width is going to be 15. This is just going to be the default brush size. And then we're going to say we're going to define here two methods. The first one is going to be classes prompt. And the second one is going to be initialize graphical user interface, so init GUI. And we're going to call those two functions, those two methods directly in the constructor. So self.classesPrompt and self.initialize graphical user interface. That's the basic idea. So those are just the attributes. We don't do anything with them. We just define them here because it's a good practice to define them in the init method, and then you can set them later on in the other functions. We define a default brush size, and then we just ask for the classes. This is the text box or the text boxes that you saw in the preview, where we have project name, class 1, class 2, class 3, and then we initialize the graphical user interface. So for the classes prompt, this is going to be quite simple. We're just going to say that the message is going to be TK, so a TK instance. We're going to say that message with we want to withdraw the message window, so we just want to have a window that we can work with, but we don't want to necessarily display a window. And then we're going to say self.project name is going to be equal to simple dialog. And I think, can we not use that from tkinter directly? Do I have to say from tkinter import simple dialog? Probably I have to do it explicitly. So simple dialog dot ask string, and then the title is going to be project name. The text is going to be please enter your project name down below. And the parent, this is why we need that. The parent of that whole thing is going to be the message TK instance. So we need to have a parent. This is why we define message equal to TK. We then withdraw, and then we just have this prompt that has the parent message. Then what we're going to do, once we get that project name, we're going to check if that directory already exists. And if yes, we're going to try to load a pickle file, a serialized file with all the information of the project, because that is something that we're going to implement later on. We're going to be able to store everything, meaning all the classes, all the samples, all the models. We can store them as a file, and if that file exists, we want to load it. So what we're going to do is we're going to say if os path exists, and we want to check if self.project name exists, because the directory of the project is going to be the project name, or the directory name is going to be the project name. And then we're going to just try to open up here the following file, fstring, and here we want to have self.project name slash, and then again self.project name underscore data.pickle. We're going to open this as reading in reading binary mode, and then we're going to say data equals pickle.load, and we're going to load the file that we open up here, sf. Basic idea is you specify a project name. If that directory exists, we're going to load this pickle file. Otherwise, we're going to create a new instance. We're going to create a new directory with new classes, and everything is going to be set up from scratch. However, if we have this data, we need to first extract all the information. So we're going to say self.class1 is going to be equal to data and we're going to have the key C1 later on. All of this will be defined when we save the project, but we're going to now just define the structure here. We're going to say that in this pickle file, we're going to have a dictionary, and this dictionary will have key value pairs, and the key C1, C2, C3 leads to class 1, class 2, class 3. Then we also have self.class1 counter. That is going to be equal to data, and the key is going to be C1C. And here we're going to have C2, C3C, C2C, like that. Then the classifier will be also part of that dictionary. We're going to just get CLF here, and the project name obviously will also be part of that. We're going to call it P name of that dictionary. Otherwise, if we don't have this directory already existing, we're going to just create a new class 1, 2, and 3. We're going to say class 1 is simple dialog.ask string. And we're going to ask here for class 1. What is the first class called? Question mark. Parent is going to be message. We're going to copy that 3 times. We're going to say class 2, class 3, class 2, class 3. And then we need the second class, the third class. And then we're going to initialize the counters being equal to 1. We're going to set them to 1, even though we have 0 instances, because we want the first instance to be called image 1 and not image 0. So we're going to say self class 1 counter is going to be equal to 1. I'm going to copy that. I'm going to set class 2 counter, class 3 counter to 1 as well. Then we're going to initialize a new classifier. So self.clf is going to be a linear support vector classifier by default. We can, of course, change that by rotating the classifier later on, but the default is going to be a linear support vector classifier. And then we're going to just say os.makeDirectory self.project name. So this creates a new directory. We then go into that directory and we create the class directories inside of that directory. So we go os change directory self.project name, and then we copy this here, this make directory, and we just replace this by class 1, class 2, class 3. And then we go back. So os change directory up 1 directory by using 2 dots. And that basically creates the project structure. So this alone already creates the project directory with 3 directories for the different classes, with the class counters initialized, all being equal to 1, and with a new machine learning model that is not trained on anything yet. That is the setup, and then we also need to display the graphical user interface. Now, this might be a little bit tedious. It's not too complicated what we're going to do here, but it's going to be quite repetitive. We just we just create a root element and then we add UI elements to that root element. But we need to go through it, so we're going to just do it here. We're going to specify the width being equal to 500, the height being equal to 500. Of course, feel free to change those values if you want to. And we're going to define the color white being equal to 255, 255, 255. This is just an RGB triple. Then we're going to say self root equals TK. And self root title is going to be neural 9 drawing classifier alpha. Since the one that's on GitHub right now is 0.1, I'm going to call this now 0.2. And we're going to make this an F string actually, because we also want to display the project name. So self.project name is going to be here as well in the title. Then we want to add the canvas. This is the most important thing. So self.canvas is going to be equal to a new canvas object, and we're going to say this is part of self.root. The width of the canvas is going to be the width, and the height is going to be the height. Or actually, since the whole window is going to be that size, we're just going to say -10, -10. And the background is going to be white, like this. I'm not sure if we're going to need that I'm just going to keep it here because I have it in my prepared code and I think it's not there for no reason, but maybe we're not going to use it. So self.canvas.pack, we're going to use pack to actually pack this into the graphical user interface. And then we're going to add a bunch of additional elements. So first of all, we're going to have self-image1. This is what we defined up here already. Where is it? There you go. This is going to be just a pillow image. So we're going to say self-image1 is going to be equal to pill-image.new, and I think we need to explicitly import pill image, right? And I think also pill image draw. So pillow.image new, we're going to say RGB, width, height, and I think this is why we need white, because here we need to pass the RGB triple. And then we're going to say self.draw. We also have this in the constructor already. Is going to be image draw, or pill.image draw.draw self image 1. Yeah, so that's it. And then we're going to say self.canvas.pack. I mean, actually, I think I can replace this with that. So self-canvas pack. Expand is going to be yes. So tkinter yes. And fill is going to be both. Those are constants from tkinter. We have them because we said from tkinter import everything. And then we're going to say self-canvas.bind. And we want to bind the event of moving the mouse when the left mouse button is clicked. We want to bind that to a certain method that we don't have yet. And how we do that is we say b1-motion. So button 1 is clicked and you move the mouse. This event of moving the mouse while you have the mouse button clicked shall be bound to the function, self.paint. And we don't have that function yet, or this method yet, so we're going to just define it. We're going to define it later on, but we just bind this now to that particular function. Meaning every time we click the left mouse button and we move the mouse, this is going to trigger that function with the event. So we also pass here an event. We're going to take care of that later on, but that's what we're going to do here. Then we want to create a button frame. So btn frame is going to be equal to tkinter frame, which is going to be part of self-root. We want to say button frame dot pack. We want to say fill on the x-axis, so x basically, and side is going to be tkinter, or actually we don't need to say tkinter. We can just say bottom, since we import everything from tkinter. And then what we want to do is we want to configure the columns. So we want to have 3 columns because we're going to have 3 buttons for the classes, and then we're going to have buttons below that. But what we want to do here is we want to say button frame dot column configure 0 weight equals 1, and I'm going to copy that 1, 2. So we have these columns now that are equally weighted. And then we can add the buttons. So we're going to say class 1 button is going to be a new button with which is going to be part of the button frame. The text of this button, not the text variable, the text of this button is going to be self.class1. The command of this button, so what happens when you click on the button, is going to be a lambda expression, which is going to call a function called self.safe with the parameter 1. This is why we want to have a lambda expression, because we want to pass the value 1 to that function, because whatever is on the canvas will be saved for class 1. Now the save function does not exist yet, so we're going to create it. I always keep saying function. It's actually a method since we're in a class. But we just pass 1 here as a parameter. And then what we do is we say class 1 button dot grid, because now we have a grid layout, so we're going to use grid, not pack. We're going to place this as at row 0, column equals 0, and we're going to make it sticky, meaning it's going to be west plus east. Now, what's the problem here with the one unexpected argument? Because we don't get a class number here. We can copy this now. We can paste this and replace 1 with 2, and here as well, and here as well. Rest should stay the same, other than the fact that the column is 1. We can copy this again. We can change this to class 3. Class 3. Column is going to be 2. Class 3 and save 3. Those are the 3 class buttons that we use to take a drawing and add it as a sample, as a training data sample for a respective class. The functionality will be implemented down here. After that, we need to also have a brush minus and a brush plus size button. So we're going to change the brush size with one button. We're going to increase the brush size with one button. We're going to decrease it with another one. So BM underscore button for brush minus button is going to be a button, part of the button frame, with a text that is going to be brush minus. The command for that will be self.brush minus. And then we're going to just, I can copy this here, change BM button. We can say row 1, column 0, sticky is going to stay the same. And actually, I think the rest is quite similar. Now I can paste this now 2 times. The one down below here is going to be BP button for brush plus. Like this, brush plus. We need to add these methods again. We're going to place this at column 2. And here we're going to have another button. It's going to be the clear underscore button. So clear underscore button. It's going to be clear. And the function is going to be self.clear. And the column is going to be a 1. Again, a method that does not exist yet. So we're going to add them here and implement them later on. Brush minus pass brush plus and then clear. All right. And then we have I think 2 more rows. So we're going to have here, maybe I can copy this still. So 3 times. We're going to just change the text and the function. So we're going to have a train button so that we can actually take the images that we already have as sample data and we can train the model on those images. So train model self.train underscore model. Again, a method that we need to implement. Train button, second row, first column. As I said, this will be a little bit tedious because it's quite repetitive, but we need to have the graphical user interface. Hopefully you will find timestamps in the video, so if you want to skip the graphical user interface part, you can just do that. But then we're going to also have a save button, which is going to be for saving the model. And it's going to call the function save model, not the function save. Save button. This is going to be row 2, column 1. And then we're going to have, obviously, a load button as well. Load button. Load model. Load model. Load button. And row 2, column 2. And now we have one last row where we're going to have the change button. So we're going to be able to rotate the model. We're going to be able to make predictions, and we're going to be able to save absolutely everything. So I'm going to just copy this here. I'm going to paste it down below. We're going to have a change button. Change button. And it's going to be with the text, come on, change model. Rotate model is going to be the function, because rotate is actually a proper term here, because we're going to go full circle all the time. We're going to have this in row 3, column 0. We're going to have this in row 3, column 1, and row 3, column 2. Here we're going to say this is the predict button. It will have the text predict, and the function is going to be predict. And we're going to say predict button. And finally, we're going to have the save_everything button, which will have the text save everything, meaning the model, the classes, the instances, everything. And it's going to be save_everything. Yeah, save everything button. All right, and the last thing that we need here as a UI element is going to be a status label. So we're going to say status label is equal to label, part of the button frame. The text is going to be an F string. It's going to say current model will be whatever the current model is. So self, or actually we need to do type self.classifier, and we want to get the name, so __name__. This will give us, for example, linear SVC, random forest classifier, and whatever. And then we're going to say self.statuslabel.config. We want to change the font a little bit. We want to say that the font is equal to Arial 10. And then self.statuslabel grid. It will be row 4, column 1, so that it's somewhat centered. And it's going to be also sticky to west plus east. And now to finalize everything, we say self.root protocol. Protocol meaning we want to associate a function with the following event. When we delete the window, so when the window is being closed, we want to call a function on closing so that we can ask the user if they want to save. Self.root attributes, we're going to set top most being equal to true so that it always stays on top. Now this is optional. If it annoys you, you can just remove it. And self.root main loop, not like this. Self.root main loop starts the whole process. All right, that is the graphical user interface. Now we have all these functions or methods that we need to implement. So we're going to just define them down here. Train model was one. Then predict was one. Rotate model was one. What else did we have? We had save model, load model, and save everything and on closing. Okay, save model, load model, save_everything, and on closing. Maybe we're going to change the order here. What we're going to do first now is we're going to do some basic functions that are easy to implement. So we're going to do the clear function, the brush plus, and the brush minus function. That's quite simple. So the clear function just says self.canvas.delete all. Basically clears the full canvas. Self.draw.rectangle. We're going to draw a rectangle from 0 to 1,000, 1,000, which is going to be filled with white. Why are we doing that? Because just because the canvas is clear doesn't mean that the image that we're drawing, that we're actually keeping track of, that we defined, where did we define it? Here. This also needs to be cleared. So we're just going to draw a fully white rectangle over it. That's the basic idea. And now for the brush plus and minus, for the minus, we have to make the check if the brush width is above 1. If that's the case, we can decrease it. So we can say self.brushWidth minus equals 1. And for the plus, it doesn't really matter. We can go infinitely large. So we can say self.brushWidth is just plus equal 1. All right, so that's that. What else are we going to do? We're going to train the model, but maybe before we train the model, we should take care of saving the instances. So let's do the save function first, which is this one here. The save function is quite simple. What we want to do here is we want to take the class number, which is passed here in the command 123. and we want to save that respective image that we currently have in the canvas or that is currently being drawn. We want to save it into a file, and we want to take that file and put it into the directory of the respective class with the respective counter. So we're going to say here the file name for briefly storing the image so that we can resize it. We're going to say this is temporary.png, self.image1.save. So we're going to save this image. Actually, we're not going to use file name. We're going to just use temp.png directly. We're going to save that image into a temporary file. We're going to then load this image directly. So we're going to say image equals pill.image.open temp.png, image.thumbnail 50 times 50. So we're going to scale it down to that size. We're going to use anti-aliasing. So pillow image anti-alias. And then we're going to determine the class number. We're going to get the class number. If it's 1, we're going to save it in the following path: image.save fstring self.project name / self.class1 / and the name of the actual file should be then the class counter. So class1 counter in this case, .png. That is the file path, and the file type should be PNG. And then, of course, in this case, we want to increase the counter by 1 so that the next file is not saved under the same name. And then we can copy this here. We can change this to elif equals 2, no, +1 actually, but here we need to change 1 to 2. And here we also need to change 1 to 2 and here as well. And then we can copy this, paste this, elif class number is 3. Then we want to use class 3. That is that. And of course, what we want to do every time when we save, we want to clear the canvas because otherwise we need to click too much. So we just save something and then it's gone. That's the basic save function logic here. Now, painting is also quite simple. All we need to do for painting is we need to remember, painting is bound to, to the movement of the mouse when button 1 is clicked, when the left mouse button is clicked. So what we need to do now is we need to say, get the event x1, y1 is event.x -1, event.y -1. So we're just getting the current, we're just drawing a rectangle essentially from x1, y1 to x2, y2, and that's just going to be +1 and +1 here. And then we just say self.canvas.create rectangle, x1, y1, x2, y2. We're going to fill it with black color, and the width is self.brushWidth. And then we say self.draw. We also need to draw it on the actual image that we're saving. Self.draw rectangle x1, y1, x2 plus self.brushWidth, and then y2 plus self.brushWidth. And then fill is equal to black, and the width is again equal to self.brushWidth. All right, so that is the paint function. Do we already have everything that we need to store the images? Let me just see. We have train model. This is something else, something else. Yeah, everything else should be related to just training the model and using the model. So let's just go ahead and try to create an instance of drawing classifier to see if we can already start creating some images. So let's just call this project whatever, and let's call the first class here A, the second one B, and this third one C. Now we have this directory structure here, ABC, and now I can provide some samples. So A is going to be that, A is going to be that, then B is going to be that, B is going to be that, C is that, C is that, and we should have these samples now. 1 PNG, 2 PNG, and this is what they look like. Okay, so this works, everything's fine, and now we can go into the machine learning part. So now we have already a program that can draw images and store them here in the respective class directories. That's awesome. So we can now delete this directory again. And now we want to train them all on the training data. So we take the data from these directories and we just need to train whatever classifier we're currently using on that data. So we're going to say here, first thing, image underscore list is going to be a NumPy array, an empty NumPy array. Class list is going to be also an empty NumPy array. Those are basically the X and Y values. So the image array here, the image list array is going to be just a NumPy array full of NumPy arrays being the image pixels, and the class list is going to be a NumPy array full of the labels 1, 2, 3. That's the basic idea. And what we do here is we say for X in range 1 up until self.class1 counter. So we start at 1 and go up until the amount of instances that we already have. Image equals CV imread, and we're going to use an f string here. We want to have self.project name, self.class name, so class 1 in this case. And we don't want to use here now the class counter, but we want to use x, because x is, we're iterating over the images, so we're just getting x. And then what we want to do is we want to get the result. We want to read that image, .png by the way. And we want to get here just one dimension. We want to get the actual image data, the actual channel that we want to have here. So this is how you load the image. Then we want to reshape it by saying image.reshape 2500. Image equals image reshape. And then the image list is going to be np append, NumPy append to the current image list, the image in a list, so that the shape is compatible. And class list is going to be np append class list 1, since we're adding for class 1. And I can copy this now 2 times, and we can just replace. This one is not something that we should replace, but here we can replace class 1 to class 2, and here 1 to 2. I think that's actually it. And of course here class 1 counter is class 2 counter. Here class 3, 3, and that should be it. So we go through all the directories, we collect the samples, we add them to the image list, we add the respective class labels, and that is our training data. And now what we can do here is we can say image list is image list.reshape self.class1 counter -1 plus self.class2 counter -1 plus self.class3 counter -1, and we want to have 2500 as the dimension. So we just get the amount of different images, and this is the shape of the images here that we provided, because it's 50 times 50. And then we have self.classifier fit the image list in the class list, and now the model is trained after this step. So we can say, we don't want to print, we want to just say tkinter.messagebox show info neural 9 drawing classifier as a title, and then model successfully trained. And the parent of this message box is going to be self.root. All right, so now we have the model trained. Now we just need to use it for predictions. How do we make predictions? Quite simple. We get a new, we get the file from the canvas. We store it into a temporary file again. We shape it, we reshape it so that it's compatible with the model shape. And then we just essentially do the prediction and display it. So what we do is we say here, self.image1.save. We want to save it again as temp.png. We want to then say image equals pillow.image.open temp png, and then we want to say image thumbnail to resize it again to 50 times 50. We want to do anti-aliasing, image save And then we're going to save this as predicted, or let's call it predict shape.png as a PNG file. And then we're going to load this with OpenCV again to have an umpire array. So we're going to say image equals CV imread. By the way, I'm not claiming that this is the most efficient way. Probably can do it in a better way without storing and loading all the time, but this is just how I did it here. Probably this can be optimized. So we're going to read this predict shape.png file now. We're going to get, again, only the channel that we're interested in. And then we're going to reshape it to 2500 again. And then we're going to say the prediction for that respective image is self.classifier.predict the image. And then we want to say if the prediction index 0 is equal to 1, actually, I did it in a not very efficient way here. So I'm going to do it now differently than in my prepared code, because in my prepared code, I basically said, if the prediction is 1, print that. If the prediction is 2, print that. If the prediction is 3, print that. But I think we can also just say here, tkinter.messagebox show info. Or actually, no, we cannot do that. Because we cannot, no, okay, I have to do it like that. So I'm going to say if prediction 0 equals 1, we're going to say tkinter.messagebox show info neural 9 drawing classifier. The drawing is probably A, and now I'm going to use an S string here, and we're going to just say whatever class 1 is. So whatever the self class 1 name is, we're going to print that. We're going to show that in the message box. We're going to say here parent is equal to self.root. And that's what we want to do here. Now we can say, let me copy this, let me paste this, let me add an elif here, and let me say that this is equal to 2. Then we just need to print class 2. And now we can copy this again. We can say elif it's 3. We're going to say it's class 3. The reason we have to do it with an if else here is because I cannot just say class plus whatever it is, because this is an attribute name. So I just have to do it like that. That is the predict method. Now the rest of the methods here are quite simple. We need to rotate them all. We need to save them all, load them all. It's quite simple. For rotating, it's very simple. We just need to define a circular structure here. So we need to say if is instance self.classifier, if it's currently a linear support vector machine. If that's the case, we're going to say self.classifier equals, next one is going to be a k-neighbors classifier. And we're going to then say elif if the instance is a safe, if the classifier is a k-neighbors classifier. What we want to do is want to say the classifier now is going to be a logistic regression. Logistic regression. Didn't I import that? Oh no, I forgot about the logistic regression. So from, is this part of the linear model? I think so, isn't it? Yeah, there you go. And then you can continue to do that in this way. So we can say, okay, if it's a logistic regression, we're going to jump to the decision tree classifier. If it's a decision tree classifier, we're going to jump to a random forest classifier. And then we can copy this 2 more times, I think. If it's a random forest classifier, what we want to do is we want to jump to a Gaussian naive Bayes. And if it's a Gaussian naive Bayes, we want to jump back to a linear support vector machine or support vector classifier. That's basically it. And we can change the status label to display what the current model is. So self.statuslabel.config, we're going to change the text to an f string. Current model is self. Or actually type self.clf underscore name or underscore name underscore, and that then displays the model. So saving and loading is also quite simple. What we're going to do here is we're going to say the file path that we want to save them all at is going to be file dialog dot ask, and I think this needs to be imported again like this. File dialog dot ask save as file name. Default extension is going to be pickle. With open that file path in writing bytes mode as f. We're going to just say pickle dot dump self.classifier into the file, and we're going to say tkinter message box dot show info neural 9 drawing classifier model successfully saved. And the parent of this message box again is self.root. Now for loading them all, we're going to do something similar. We're going to say file path is going to be file dialog, but this time open, ask open file name, and with open the file path as reading bytes sf, we're going to say self.classifier is pickle load whatever is in the file, and then we're going to just take this message box and print mol successfully loaded. All right, and this leaves us with the last two functions, save everything and on closing. Save everything is going to be quite simple. We're going to define a dictionary where we're going to have key value pairs of some identifier and what we're trying to save. So we're going to say, as we defined up in the constructor here, I think. There you go, C1, C2, C3 and stuff like that. We're going to use those again. Down here, we're going to say C1 points to self.class1, C2 points to self.class2, C3 points to self.class3, then C1c points to self.class1 counter, C2c points to self.class2 counter, C3c points to self.class3 counter, and then we also want to have, of course, the classifier, which is going to be self.clf, and the p name is going to be the self.project name. So we take this dictionary and then we say with open, and we want to store it at the following file path. Now, why don't I see anything? It's going to be self.project name slash self.project name underscore data dot pickle, which is exactly what we loaded up at the top. So if I go back up, this is where we loaded this from. So I'm going to store it there. And we want to open this as writing bytes as f, and we want to say now pickle dot dump this dictionary here, this data, into the file, and then we can again display a message box, show info, project successfully saved. And finally, what we want to do here on closing is we want to say answer equals, we want to check if we want to save. Answer equals tkinter message box ask yes no cancel quit question mark do you want to save your work question mark parent equals self.root. And then we say if answer is not none, so if it's not canceled, and if the answer is yes, so if answer, then self.save everything. Otherwise, if the answer is not none, but it's no basically, we say self.root.destroy. And exit, just to make sure that everything is closed. And that's basically the full code of the drawing classifier. Now let's see if we did any mistakes. We need to test it first. Maybe I made some mistakes, but let's try and do again shapes. Let's go and say we have a triangle shape. We have a square shape. We have a circle shape. And now I want to provide some examples. So triangle, there you go. Triangle, triangle, triangle. Those are not beautiful triangles. So it's probably going to be a pretty shitty classifier. Let's go with square. Let's try square 2, square 3. Oh boy, those are not beautiful shapes. And then circle, 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 and circle. And let's see now if I can train the model. Linear support vector classifier is trained. Let's see if it can recognize a triangle. Predict it's a triangle. Let's see if it can recognize a circle. It's a circle. Oh, there you go. So let's change k-neighbors classifier, train the model again. Predict this shape here. It's a triangle. Okay, change the model, train it. Does it recognize as a triangle? It does. Okay, change the model, decision tree classifier, predict, triangle. Okay, great. Change the model, train, predict. Okay, works. And then we can change a couple more times. We can now save the model on the desktop, for example, or I can actually save it here at Neural 9, Python, current. So I can just store it as my model. I can save it. Model successfully saved. I can also load the model now from here. Model successfully loaded, or I can just save everything. And then I can close. I can say I don't want to save my work. Then I should have here now in shapes this shapes data pickle. And when I now open this up, so when I restart the program, hopefully, if I now type shapes, it should find that project and already know that this is a triangle. Okay, no. We need to fit still. Train model, predict. It's a triangle, okay. And square. I think we only needed to fit them all because the last time I saved. So let's try save everything again. Let's close. Let's run this again. Let's type shapes. Let's see if this works right out of the box. There you go. All right, so this is how you build a drawing classifier that that classifies your custom drawings in Python. All right, so that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video and bye.